Yeah.
All right. So number 8, you know how like in math problems, there's like certain ones that are easier and certain ones that are more difficult. This problem right here, number 8, is as difficult as this type of problem would ever get. So what I mean by that is the type where you log both sides. This is again one of my stupid Mrs. Talbot things, but this is the spiciest that this would ever get. This is spicy. This is like ghost pepper spice level. It's not really Carolina Reaper level because I don't think these problems could ever really go there. But I'm just saying, if you find this one to be challenging, it's not you, it's the problem. So I have these things all year, by the way, just mentally prepare for my silly. All right, anyway, okay. So when I do a problem like this with students, I like to pretend that this is the problem I'm doing first. So this is like a math 1 problem. I took out the base and exponent and just replaced it with x because it's much easier to see the order of operations from this than it is from this. So if I was working on the Post-it note, what would be the first thing I would do? Add 3, right? Okay, so that still applies on the log problem. Okay, and then on my Post-it note problem, the next thing I would do would be divide by -9 on both sides, and that would be the same thing I'm going to do here. And the answer is terrible, 7.966. 7. I guess it's not as terrible as I thought. Okay, now I have base, exponent, and answer. So I've gotten it down to where I can no longer use the Post-it note. I have base, exponent, and answer, and this is the spot where I log both sides. So log 16 to the 8p plus 9 equals log 7.9667. Then I'm going to use the power property of logarithms and move that exponent into the front. Divide both sides by log 16. Minus 9 from both sides. Divide by 8. Yeah. Could have written smaller, but that's okay. Okay, so if you can do that problem, then you can do any of these problems. That's as hard as those will ever get. That's as many steps as I would ever ask. Okay, when you're ready, can you flip to number 9, please? Hold on. Anyone still working on number 8? If you are, it's totally okay. All right, number 9. So number 9 and 10 are regular log equations. So we need to review how to do these. So the other two were called exponential requiring logarithms. These are actually log equations. Okay, and I start by taking a look at the operation between the two logs. And I say, okay, it's subtraction. Subtraction of exponents is, do you remember? Division. Great. Okay, so I condense the two logs with division. The first part goes on the top is the numerator, and the second part goes on the denominator. So again, subtraction means division. The first bit of the log goes on the numerator. The second bit of the log goes on the denominator. Okay, then the next question I ask myself is this the type where I do the loop-de-loop, or is it the type where I cross out the logs? Cross out. This guy over here, tomorrow, this is not tomorrow. We have a block day tomorrow. It's weird, but Wednesday we'll have a loop-de-loop one. Okay, now for me, I like to put this side over 1 and cross multiply. So 4x squared times 1 is 4x squared. And 9 times 36 is 100, no, it's big. 324. Divide by 4. Square root. And I got 2 answers, plus and minus 9. Okay. Now you guys seem to have moved on, but notice I have not moved on. Do you remember with log equations, you actually have to check them for extraneous solutions? Do you guys remember how to check them for extraneous solutions? Yeah.
Plug them both in and can't take the log of a negative.
Correct. Except, what do you notice the first thing that happens in this one? Before the log. It's squared, which is going to make it positive. Okay, so anyway, I like to check these in the calculator. I'll go to log base. Log base 8 of 4 times 9 squared minus log base 8 of 9. And what am I hoping that that equals? The other side, right? Log base 8 of 36. Do those things equal? Yep. Okay, so we know positive 9 works. Now for negative 9, this is going to be interesting. Kind of a advanced use of the calculator. You have to hit the right buttons though. Okay, what did I do? Yeah, I took the 9 and switched it to -9, but I was really careful to make sure that my -9 was in parentheses. So I have parentheses in parentheses. That means that -9 works also. Now you might have just said to yourself, I don't really need to plug that second one in the calculator because -9 squared is the same thing as 9 squared. So if you just thought about it, you'd be like, oh, they clearly both work because you square it. But if you're a calculator lover, you might want to type them in to check. Okay. All right. I think we are done with the packet for the moment. So scooch that guy aside. Okay, so in I don't know if you guys noticed, but all last week when we were working with polynomials, they all crossed the x-axis at nice numbers. Did you guys, anybody notice that? They crossed at like 1 or 2 or like -4. So this week, we're gonna talk about what happens when they cross the x-axis at gross number, bad number. By gross and bad, I mean decimals or square roots or don't cross at all, foreshadowing. Okay. So first question I have for you is, what are these things? They're all the same shape. What are they? Parabolas. They're all parabolas. Okay, great job. And what degree are parabolas? What degree are these three? They all have that in common. How many x's does this have? 2. How many x's does this have? 2. How many x's does this have? 2. Okay. This is really important. Okay, now if I asked you to find the roots of that first one, you would probably be upset with me because you would need to multiply out that box. Then you would need to refactor it and figure out the roots from factoring. I'm not going to ask you to do that today. What I want to do is look at Desmos and find the roots. Okay, but here's my question. Before I go to Desmos, how many roots should it have? 2. And how many directions should it have? 2. Okay. So you should have some expectation there. And here it is. So this is the one that we just were looking at. It has two roots, two directions. My roots are at 0 and 4. Can you guys see them okay? Okay, so what I want you to do is I want you to write x equals 0, x equals 4, and then we're going to start adding a new type of description. This is called two single. That's supposed to say single with an N. Single real roots. Okay, last week we just didn't write anything when they were single. We just put like double in parentheses, right? Okay, so now we're making a new distinction. We're calling them single, which means it just passes through. And we're calling them real, which hopefully is making your brain go, okay, what if they're not real? Why are we saying that? Okay, anyway, now let's go to this one. This one's degree 2. It should have two roots and two directions. Does that make sense? This one, B. Degree 2, two roots, two directions. Yes? Okay. So I'm going to turn off A and turn on B. Okay, what is this situation? It's a bounce, right? It's a double. You guys remember the double from last week when it bounces off of the x-axis? Okay, so we're going to say x equals 2. One double real root. It's really important to me that you guys understand that two singles count as 2 and one double counts as 2. Everybody good there? Okay, now we're going to get to the weird one. This guy, it's a parabola, degree 2, should have two directions and two roots. Uh-oh. Is it crossing the x-axis at all? No. Okay, but are there two directions? Yeah, there has to be two roots. That's like a rule. So it's called two single complex roots. Does anybody know what complex means? What's another word for complex in this class? Does anybody know? You might not know. Imaginary. And why do you think that we were working with eyes in our warm-ups last week? And the eye and the quad formula and that one homework problem? That's because the roots for these are going to have eyes. Okay, so number 56, we have this problem and we're actually going to find the roots. And they should have eyes in them. Okay, 0 equals x minus 2 squared plus 3. So remember, when you're finding roots, zeros, or solutions, you set y equal to 0. Minus 3 from both sides. Okay, now I have a squared I need to undo, and you can sort of pick up what I'm laying down right now because I'm going to square root both sides. And what's this going to be? Negative, right? Okay. I'm going to pause right there because I'm missing something. Does anybody know what you have to remember when you square root both sides? Plus or minus? Okay, so -3 simplifies to I root 3. So the negative comes outside and becomes I. Okay, and you want to put the constant in the front because you want it to look like a quad formula answer. Okay. Let's talk about the vocab here real quick. First question. Why are they complex? Because there's an I. Why are they single? Why is this not double? Because one of them is positive and one of them is negative. They're different from each other. They're not exactly the same thing squared. One of them's positive and one of them's negative, which makes them single. You guys see the difference? They're not exactly the same thing. They're opposites of each other. Okay, go ahead and set up 57. Okay, these are two single complex roots. We already learned that, but they're called also complex conjugates. This is a new vocab word for us. Conjugate means that they always go together. Okay, there's going to be a day. I don't know what day it is. It's not today. It's in the future. A day in the future where I tell you to find factored form or standard form given some roots, and I'm only going to give you one of these, and you in your brain are going to have to say, oh, well, because of the plus or minus, if this one exists, then this one also exists. I'm not going to do that to you yet. I don't know exactly when the day is, but at some point in the math, they just start taking away the second one, and you actually have to have the thought, oh, if it's got the positive, then it has to have the negative. When does that happen? With I. Because you square root both sides and the plus or minus. There's another time it also happens, and that's when you have just a regular square root without an I. These would be called two single real roots. Because the square root of 2 is not imaginary, it's just a decimal. It's a gross decimal, but it's not imaginary. And these are called irrational conjugates. That's supposed to be a C. I don't know what happened. And you need to make sure that you always have both because of the plus or minus. Either the plus or minus in square rooting both sides or the plus or minus in plot formula. Either way, there's always a plus or minus. Okay, now I don't know where you guys are in the middle of your paper. I'm gonna do the notes part. I'm gonna flip my notebook over and start it at the top of the other side. If you have a lot of room, you don't need to do that. There's like, I think 4 examples in the notes. You can probably fit 2 of them on this side and 2 of them on the other side. I don't know. My students always tell me I use a lot of room. and I could be like really, really condensed, but I can't do it. I have to have a lot of room. So anyway, I'm gonna flip my paper over. But if you have a bunch of room, you can totally feel free to just keep going. Okay, you guys, so we've already been practicing this. We already did this type of problem last week. So I want to use this type of problem to help us start to work on the ones with eyes and roots. But hopefully, um, hopefully it will make sense with the eyes and roots after we do this guy here. So what I'm doing is I'm telling you that these are two roots, and we're going to get the equation in standard form. Okay, so start with y equals x, switch the sign, x, switch the sign. So I'm taking them from roots to factors. Roots to factors. Okay, now on my video from the worksheet, what did I say to do with a fraction? Do you remember what I said to do with a fraction? Yeah, so in this one, multiply both of these by 4. Do you guys remember that? Anybody else remember that from the video, I hope? Okay, and now we're going to do the box to multiply them out. So much easier to do the box if you don't have the fraction. Okay, now in this problem, this is the final answer. However, I need you guys to all know that this one is only one possible equation. It's not the equation. It's only one possible equation. Why? Because I didn't give you a coordinate and have you solve for A. You don't know what A is. So if I had said, comma, and passes through X, Y, you would have to plug in the number for X and Y and solve for A. But we're not doing that part right now. We're just practicing this part. And at some point, I'll bring those two together. So not today. Okay, now we're gonna do the one with I. And I actually really like these because they're less work. So can you tell that these are complex conjugates? Okay, great. So we're going to start doing exactly the same thing we did here. We're going to say X, switch the sign, X, switch the sign. Just like we switched the sign on these two. Switch the sign, that one goes there. Switch the sign, that one goes there. Do you guys all see this one comes from this one comes from this. The switch sign is the whole thing. Okay, 2 by 2 box. And now you're going to start to see what I really like about conjugates. Okay, first box is x squared, negative 3ix, positive 3ix, negative 9i squared. Okay, make sure that you're good with the parts of the box. Okay, now negative 9i squared. What is negative 9i squared? 9. Because remember, I squared is negative 1, and negative 9 times negative 1 is positive 9. Okay, here's the thing I love about conjugates. If you have a 2 by 2 and you're multiplying conjugates, this box and this box will always cancel. And you don't even need to fill them in. As a matter of fact, as we go through these, I'm just going to cross those two boxes out and not even find them. It's going to be great. Okay, so my final answer is y equals x squared plus 9. X squared from here, 9 from here. And then let me say again, the problem's technically not perfect because I didn't give you a coordinate, tell you to solve for A, but. Okay. Are you guys okay with these two before we move to the two? This is the easy ones, by the way. These are non-spicy. These are like, I wouldn't say they're mild. I would go like a medium. Do you like your salsa medium? I'm a mild girl. Okay, but I recently discovered this stuff called guacamole salsa. Have you seen the guacamole salsa? It's like in the green bottle. It's like green and no, it's really, really good. It's really salty. I like salty stuff, so you should try it. Really, really good. Just, really Target, Safeway, guacamole salsa. Give it a go. Just give it. Okay, and then I need you to lock in. Okay. First, for C, can you tell that these are complex conjugates? Okay, great. And complex conjugates are awesome because stuff is going to cancel out in the box and it's going to be super satisfying. Okay, however, this is the part I need you to lock in for. So y equals, and you remember how up here we did x and then we switched the sign, and then we did x and we switched the sign. Do you remember that? And we did x and switched the sign and x and switched the sign. Okay, now there's two things in our root. So we have to go x, switch the sign, switch the sign. X, switch the sign, switch the sign. I really want to make sure you guys see that this root is going to that factor and this root is going to that factor. You have to switch the sign on both things. Okay, and what does this mean? This means we need a 3 by 3 size box. Oh, fun. You didn't think you were going to have to do a 3 by 3 box when you woke up this morning. But I promise you, it's going to be satisfying because a bunch of stuff's going to cancel. That's the best thing about conjugates. Okay, let's see if we can discover the boxes that get to cancel. So x squared negative 5x negative 2ix, negative 5x, positive 25, be really careful, positive 10i, positive 2ix, negative 10i, negative 4i squared. Okay, which boxes cancel out? This guy, and that will happen every time. And this guy, and that will happen every time. And what does negative 4i squared equal? Positive 4. Okay, so I'm going to do 2 bits of combining like terms. I'm going to combine like terms on these two. And I'm going to combine like terms on those two. So my final answer is y equals x squared minus 10x plus 29. Do you guys all see where the 29 came from? Alrighty, we got one more. And then we need to talk about your quiz on Friday. And then I'm going to do as much stamping as I can, starting on this side over here. Because I think I didn't make it to these 3 tables, I think. Okay. All right, last one. These are called irrational conjugates. They kind of look like quad formula answers. That's about right. Y equals. Okay, we're going to go really slow one more time. X, switch the sign, switch the sign. X, switch the sign, switch the sign. Okay, now 3 by 3. Irrational conjugates are just as satisfying. Stuff is going to cancel in the same spots, but I want to prove it to you, so I want to do the problem out. That's not the prettiest root 2 I've ever made. Okay, x squared, 3x, negative root 2x, 3x, 9, negative 3 root 2. Positive root 2x, positive 3 root 2. Okay, this is, let's be very careful, negative root 4. What is negative root 4? Nope. Negative 2, right. So you can just get rid of the root. Okay, now what boxes cancel? It should be the same ones because that's the same pattern in all of these 3 by 3s. Y equals x squared plus 6x plus 7. Everybody see where the 7 came from? Okay. All right, we're done with that. Grab your stamp sheet, please. Take a look at your stamp sheet. We need to talk about this week. Okay. So, May through 12, we just did 55 to 57, 63 of the notes. Tonight's homework is the chapter 8 quiz 1 review. It is in your packet. I highly suggest you do it without a calculator. Try your bestest to not touch the calculator when you do it. Tomorrow, you do not have me because weirdly this week block days are on Tuesday and Wednesday. So you have me on Wednesday. On Wednesday, we will be doing the math testing class. So what? It's gonna be elective fair and open house, they move the block days early, I don't know. Anyway, so your homework is gonna be the same. It's not gonna be due that day, so your quiz review is not due until Thursday. So do it slow and careful, I'm saying. On Thursday, we're gonna do learning stuff. And then on Friday, we have a worksheet and a quiz. Let's talk about the quiz. By the way, you need to bring a charged Chromebook tomorrow, not tomorrow. You don't have me tomorrow. I can't adapt to different block days. I can't do it. Bring a charged Chromebook to class on Wednesday. Really strange. Okay, anyway, here is your class. This is Google Classroom. Let's take a look. The first quiz of the semester will be Friday, January 16th. No calculators allowed. The quiz will be the last 10 minutes of class. There's two problems. First, you're going to have an equation. It's going to be in factored form. Do you know what I mean by that? Like parentheses. You're going to state the degree, take the root, and sketch the graph. We did that in problem 8-31. We did a couple of those. They're also on your quiz review. Okay. The second problem is like the ones we did on Friday. So you have a graph. You write down the equation off of the graph with an A in the front. Plug in the point for X and Y, solve for A, and write the equation. And this one is going to say factored form. You will not need to multiply it all out. Okay, what problem was that like? 8-43? 8-43 would be a really good one to look at from Friday. You guys know what those things are, what that means? Okay. All right. So start working on your quiz review, please. I'm going to stamp as much as I can.